In this video, I would like to share my screen and take a look at some combination of how we combine transformations. So we've talked about horizontal shifts, we've talked about vertical shifts and reflections, as well as stretching and shrinking. But I'd like to do some examples that combines all those together in one function. So I'm going to share my screen and we're going to go into Desmos. And so I'm going to be working with the x squared function. So in Desmos, you can type y equals x squared like this, which is the basic parabola having a vertex at the origin. Or you don't have to put y equals, okay? Either way, if you just type x squared, it's assuming you mean y equals x squared. So here's our basic parabola. Now let's just show you what happens. So typically when you do these, when you're graphing these combinations of translations and transformations, you're going to do it in a certain order. So you get your basic shape here. And let's suppose, let me do another function, the final function, which that I want to graph is -2 x minus 3 squared, and then plus 2. So if you look here at this function, the blue function here, we've done a few things here. We've translated the function. In other words, we've shifted it around. And remember, inside the square, so the function is our square. The square here is on the x. So that's our basic function as I've graphed it. That's what's graphed in red there. Now we're shifting it to the right by 3 because we're subtracting 3 on the inside of the square. And on the outside, that's going to give us a vertical shift. We're adding 2, so it's going to go up 2. So you're going to shift to the right 3 and up 2, and then you're going to stretch it by a factor of 2. So everything that would have been at a height, let's say, of 1 is now going to be height at 2. Anything that would have been at a height at 2 is now going to be at a height of 4. So it's just going to be stretched vertically. And the reason why it's stretched vertically is because the 2 is on the outside. And so anything that happens on the outside is going to be vertical, and anything that happens on the inside is going to be horizontal. So the negative here is the reflection, and because it's outside the function, it's going to be across the x-axis. So you can see our final function here that is a combination of all these different translations or transformations. And now I'm going to show you with the red curve how we get there. So the first thing that you're going to do is stretch it. So I'm going to multiply by a factor of 2. Okay, so now you can see I've stretched it. Then I'm going to reflect it. So now I'm going to put a negative in front, and now it's going to flip it across the x-axis. And that's because it's on the outside of the function. And now comes the translation. You're going to get your shape and your reflection first, and then you're going to translate it, which is shifting it around. So now we're going to shift to the right 3. So I'm going to go ahead and inside the function. So I'm going to use parentheses here. So it's inside the square. And I'm going to subtract 3, and that's going to shift to the right 3 units. And then finally, on the outside, we're going to shift up 2 units. So that's how we get our graph. And now you can see it's matching over the blue, which is what we wanted. Okay, so I just wanted to show you how individually we go about analyzing these graphs, or or at least the change in the graphs when we're combining the translations and the transformations. Let me do another example. Okay, so I'm gonna get rid of these two here. And this time I want to use the basic function y equals the absolute value of x. Okay, so there we have our function. Now, one thing you'll notice, if I reflect this function across the y-axis, in other words, if I put a negative inside the function, nothing changes. And that's because I'm reflecting, since the negative is inside the function, it's reflecting across the y-axis. And if I do that, this curve goes over here, and this curve goes over here, and it's the same function. But if I put it on the outside, so now I'm going to put it on the outside, it's going to shift it across, okay? But before I do that, I want to, this time I'm going to shrink it instead of stretch it. Shrinking is multiplying by a fraction, less than 1, or between 0 and 1. So this time I'm going to do 1/2, and you can see what happens, it flattens it out. And that's because the 1/2 is on the outside, so vertically it's going to shrink it, and that causes it to compress. I noticed in one of your homeworks, I think it was number 16, well, anyway, in one of the homeworks problems, I'm not sure what number it was, it gave the wrong answer. There was a fraction in front, and it was supposed to compress it, and it actually stretched it. So I don't know if you ran into that problem, but let me know. I'm curious. I had that problem show up where it was giving me the wrong answer. So it was marking my answer wrong, and I knew it, I was right. So watch out for that when you're doing your homework. But anyway, as you can see, when you multiply by a fraction between 0 and 1, it's going to compress it. And then you put the negative in front, that's going to reflect it. And then you shift. Let's say we're going to go to the left now, 4 units. So we're going to go to the left, 4 units, and then down 3. And we've lost our graph, but I can zoom out here and you'll see it there. Let me get rid of this bar here. Okay, so there's our graph. We have, we took the basic absolute value. Let me go back to that and put that in. So we started with y equals the absolute value of x. Okay. And we flattened it out by a factor of 1/2. And then we reflected it across the x-axis, shifted it over 4 to the left. That was +4 on the inside. And then -3 on the outside takes me down 3 units here. So you should try Desmos and play around with some of these functions, and it'll help you understand what's happening. All right, I'm going to log off now.